Alright, this is a tutorial on how to convert units that are more complex. For instance, this one says the fastest man, Usain Bolt, ran the 100-meter dash in 9.58 seconds in the Olympics the other year. And we want to know how fast is that in miles per hour. So we will need to convert both meters to miles and seconds to hours. And some people might say, but I can't do that, there's just too many units. Well, what we're going to do is we're going to focus on converting first one set of units, and then we're going to convert the other set of units, but it'll all be in one problem. The first thing we have to do is we need to make this a little more easy to work with. It's a 100-meter dash in 9.58 seconds, and if you take 100 divided by the 9.58, you end up with 10.4 meters per second. Now this unit is a unit over top of another, so we are going to call it a complex unit. And we're going to convert, just like we've been doing with simple problems, we're going to convert the meters into miles, and we're going to convert the seconds into hour. Alright, so there are some conversions that we know or that we would be given. We know all the time ones, so 1 hour is 60 minutes. We know that 1 minute is 60 seconds. We know that 1 meter from the metric system is 100 centimeters. We know that that 2.54 centimeters are equal to 1 inch. I know that there are 12 inches in 1 foot, and I know that there are 5,280 feet in 1 mile. I believe that that's all the conversions, all the factors that we're going to use to solve this problem, but it helps sometimes to identify what kinds of things we could be using when we're solving these problems. So now we're going to line up all of our units. We have our 10.4 meters per second, so we have to draw our first conversion, and it doesn't matter whether we start with the meters or the seconds. Meters is on the top, so I'm going to go ahead and pick that one first. I like to use the top unit first. Meters will go on the bottom of the next fraction. Now on the previous screen we saw that there was 1 meter is 100 centimeters. Alright, so we're not there yet. We got to keep going because we are looking for miles per hour. Alright, so we're at centimeters. Centimeters is on the top of this fraction, so we're going to put centimeters on the bottom of the next fraction, and we said that there were 2.54 centimeters in every 1 inch, and we also had that there were 12 inches in 1 foot. Now I chose to put inches on the bottom so that I could cancel from up here down here. Okay, so I'm not done yet. Miles is what I'm looking for, and I have feet, so I'm going to put feet on the bottom and miles on the top, and I know that there's 1 mile is 5,280 feet. Sorry, that zero is a little mushy. We're not there, but I've run out of room, so I'm going to continue converting on the next line of my paper. So I have miles up here, so miles will go, nope, miles will stay because we want miles as part of our answer up here. So we're done with the top half. We are going to now convert our seconds to hours. Seconds is on the bottom of this fraction when we're beginning. So in order to convert it, we wouldn't put it on the bottom. That wouldn't cancel. So seconds will go on the top of the fraction that we're working on, and we will put minutes on the bottom because we know that there are 60 seconds is 1 minute. Next fraction, seconds are canceled, so now we have minutes on the bottom, so minutes go on the top, and we're going to go to hours. There are 60 minutes in 1 hour. So we should be done with this problem. Let's go back and check our units. We have meters canceled, we have centimeters canceled, we have inches canceled, we have feet canceled, and we do indeed have miles. Now looking at the rest of our units, we had seconds on the bottom and seconds on the top. We have minutes on the bottom and minutes on the top, and we have hours on the bottom. So our end answer will be miles over hours. So if you take the 10.4 times 100 divided by 2.54 divided by 12 divided by 5,080 times 60 times 60, you end up with 23.26 miles per hour. Here's a graphic that I found online of his run, the world record run, and you can see at the various times how many steps he's taken, how fast it was in meters, and then how far he was along in the meters, and then how many miles per hour he went. And they have the 9.58 going at 26.40 miles per hour. Now, some of the change in the tenth place is due to not having completely correct and accurate conversion factors. So anytime you convert something, it could round a little bit differently.